And hello, everybody. Many thanks for inviting me to speak today. And I'd like to give you an overview of two projects that are really designed to complement the functionality provided by the brokers with some flexible tools that will give users the customizable tools that they can do their science with their particular workflow. Of course, before I go any further, I want to give all credit to the many people who are involved in both of these projects. Several people are attending this workshop, and of course, the many collaborators we've had in the community. So thank you to all of you. For context, here is the overview of the ecosystem that we see these tools operating in. Our aim is to provide complementary functionality, as I've said, with the brokers and to interface with those services, and to provide astronomers with some useful, user-friendly tools to allow them to collate information from multiple sources on the targets they care about, and to achieve all of their science aims, recognizing that each product will have their own unique needs. As you all know, deriving science from an alert stream is a pretty intensive workload. There's a constant stream of alerts, there's new discoveries to be evaluated, often under time pressure, and they all are at different phases of evolution. Projects need to be able to collate information from many different sources, explore it and visualize it, and the different teams have different workflows with different displays needed, etc. And in many cases, the projects also need to obtain additional data. So there's, as we just heard from Fritz, the constant cycle of requesting observations from many different instruments and reducing and analyzing those data. So several teams have independently developed database tools to manage their products and all of the associated data. And the Fritz system is one terrific example that we just heard about. As a general category, I refer to these as targeted observation managers, also known as marshals. One thing about all of the TOM systems, though, is that the developers had to invest substantial effort to learn about databases, software, and IT. And that's time taken away from research that most astronomers are paid for. So it's expertise that isn't necessarily always available at all institutions. And as these tools can be a very powerful way to enable a science program, that raises an equity issue. So the goal of the toolkit, the TOM toolkit, was to provide an open source set of tools that provide the widely used functions and interfaces to the services like brokers that astronomers are going to need, so that users avoid having to constantly reinvent the wheel, but implement them in such a flexible way that they can be customized to the needs of each science project. At the heart of the TOM is a customizable central database. The toolkit provides interfaces to several alert brokers, as well as data catalog services such as Simbad, so users can pull in data from multiple sources, as well as to a number of programmably accessible telescopes. It also includes a number of observation planning tools to support more traditional observing runs, such as target visibility calculators, finder charts, etc. We provide a browser-based display and data visualization tools so that the TOM can be easily accessed by team members around the world. And the Django-based framework automatically supports mobile as well as desktop devices. It's also important that a TOM system be able to interface with user-developed software, because each project has its own preferred software for doing the modeling, for doing analysis. So we provide a RESTful API to enable that interaction. I'd like to give a quick update on a few areas of recent development work. Coordinating observations of transients is one of our most technically demanding use cases, and its perfect example of this is multi-messenger astrophysics. Our team are collaborators in the SIMA initiative, and we're making sure that the toolkit is integrated with their alert platforms. An important aspect of that work is it closes the loop between brokers who serve alert information and observers feeding information back upstream based on the information they derive from their observations. Part of the work of that has led us to explore some more sophisticated in-browser tools for tabulating and visualizing data. We're exploring apps developed with the Postly Dash interface as well as Vue.js to give users more control, such as sorting and sorting on tables, etc. We're also starting to make use of the toolkit for our own network observations. We wanted to upgrade our software for scheduling routine instrument calibrations, and it made sense to use the toolkit to build the replacement system. And the system has recently begun to handle spectrographic standards for our NRES instrument across the network. We place a strong emphasis on supporting our users and the community in general, so I wanted to include links to our documentation and all of the online training materials we've provided. And we also offer a public Slack channel where anyone who's interested can come and contact our team and work with our development team. Now, although observation programming is only one element of what TOMs will do, obviously TOMs are particularly powerful when they can directly interface with the wide range of observing facilities. And to prepare for LSST follow-up, the AEON collaboration was formed between Las Cumbres, SOAR, Gemini, and Noir Lab, with the goal of enhancing our capabilities for time domain science. We've developed 2 alternative channels for telescopes to partner with AEON to give the maximum flexibility but keep simplest possible technical requirements. Telescopes agree to allocate at least some of their time to Q-scheduled observations and to provide programmatically accessible interfaces, which should be compatible with the TOM toolkit. Las Cumbres, as perhaps many of you know, is a network of fully robotic telescopes sited around the world. It uses dynamic scheduling software to optimize the sequence of observations conducted at all telescopes, and the TOM toolkit includes a module that's designed to talk to the network API. By contrast, the SOAR 4.1 meter telescope is a manually operated facility in Chile. They operate a traditional block schedule most of the time, but they agreed to designate specific nights to run in Q mode observations, during which SOAR takes advantage of the LCO scheduling system. That means that SOAR users can also take advantage of TOM systems. Both of the Gemini observatories operate their own Q-based schedule almost all of the time, and users are able to submit programmatically requests through the Gemini observation tool. To interface with AEON, Gemini staff developed an interface module for the TOM toolkit, which enables users to submit requests directly to the TOM via their API. The technical requirements for an observatory to become compatible with AEON are deliberately kept low and non-invasive to implement to encourage other facilities to join the partnership and so increase the range of facilities that will be available to users.
2 minutes left.
Thank you. So in addition to our current partner facilities, we're working with a number of other observatories, including the Liverpool telescope, to implement additional TOM plugin modules so that users can access their services. I hope I've given you an overview of the whole TOM and AEON projects and some of the directions of our recent work. I'd like to wrap up by posing a few of the questions that I think are important to discuss at this workshop. Firstly, the end goal is, of course, to enable everybody's science from the alert stream. And my sense is that the most robust way to do that is to make it easy to access information from multiple sources of information. But we also need to be aware that brokers provide a service which users rely on. So any updates to one system has a knock-on consequence downstream. And I wondered if it's something to consider that maybe we need a common system of notifying all other services in that ecosystem of any upcoming changes so that all other services can adapt. And lastly, I'd like to take this opportunity to thank all of the teams who have partnered with us to create interfaces and plugins for the toolkit, and to emphasize that our team is very happy to work with the community and build the best tools that will give us all the science we want. Thank you.
Thank you, Rachel. We have 30 seconds if anyone has a quick question. Otherwise, we can move on to the next talk, and you can ask them on Slack. So there seems to be a question on the chat saying updates are hard. Yes, upgrading Kafka is scaring me. Will need huge coordination effort.
I think a coordinated effort is something that would be valuable across the community, yeah. I'm not sure how best to do that, but I definitely think it's worth considering.